Lecture 10.2, Day 2, Vector-Valued Functions. To start today, I have a series of photographs of Everglades National Park. I just couldn't pick my favorite. Any vector v in component form AB can be written as a linear combination of two standard unit vectors, I, which is the vector 1, 0, and j, which is the vector 0, 1. V equals vector AB equals A, 0 plus 0, B. Or A times vector 1, 0 plus B times vector 0, 1, which is AI plus B, J. The vector V is a linear combination of the vectors I and J. The scalar A is the horizontal component of V, and the scalar B is the vertical component of V. This might be a good time to point out that the standard typeface for vectors is a boldface type. Which doesn't show up well in my handwritten notes, but comes out pretty clearly on the PowerPoint lectures. We can describe the position of a moving particle by a vector r of t, that is, r as a function of t. If we separate r of t into horizontal and vertical components, we can express r of t as a linear combination of standard unit vectors I and j. That is, r of t equals f of t I plus g of t j. In 3 dimensions, the component form becomes r of t equals f of t I plus g of t j plus h of t k. Now we can try graphing on the TI-nspire using parametric graphing. We'll graph r of t equals t cosine ti plus t sine tj, where t is greater than or equal to 0. Press Menu 3, Graph Entry Edit 3, Parametric. Insert the parametric equations and the range. Press Enter to see the graph. We can zoom out to see more of the graph. And use Trace to see the velocity increase as t increases. Most of the rules for calculus of vectors are the same as we have used previously, except speed is the absolute value of velocity, but in this case, absolute value means distance from the origin, so we must use the Pythagorean theorem. We can't just drop a negative sign. Direction is equal to the velocity vector divided by the speed, or v of t over the magnitude of v of t. Example, r of t equals 3 cosine ti plus 3 sine tj. A. Find the velocity and acceleration vectors. Just as we have been doing for much of the year, velocity is the first derivative of position. So we get v equals dr dt equals negative 3 sine ti plus 3 cosine tj. Acceleration is the derivative of the velocity, so we get the acceleration equals negative 3 cosine ti minus 3 sine tj. B. Find the velocity, acceleration, speed, and direction of motion at t equals pi over 4. The velocity at pi over 4 is negative 3 sine pi over 4 I plus 3 cosine pi over 4 j, which is negative 3 over radical 2 I plus 3 over radical 2 j. Acceleration at pi over 4 is negative 3 cosine pi over 4 I minus 3 sine pi over 4 j, which is negative 3 over radical 2 I minus 3 over radical 2 j. Speed is the magnitude of the velocity, which is the square root of negative 3 over radical 2 squared plus 3 over radical 2 squared, or the square root of 9 halves plus 9 halves, which is 3. Direction then is the velocity vector over the magnitude of the velocity vector, which is negative 3 over radical 2 divided by 3i plus 3 over radical 2 divided by 3j. And for those of you in my class who know how much I hate diagonal vector lines, I ran out of room, so I made an exception. So here we get negative 1 over radical 2i plus 1 over radical 2j. And look, no diagonal division lines. Another example, r of t equals 2t cubed minus 3t squared I plus t cubed minus 12t j. A. Write the equation of the tangent where t equals negative 1. First, we'll find the velocity vector. V of t equals dr dt equals 6t squared minus 6ti plus 3t squared minus 12j. Now, to write the equation of the tangent line, we need a point and the slope. At t equals negative 1, r of negative 1 equals negative 5I plus 11j. V of negative 1 equals 12I minus 9j. The position then is negative 5, 11. That is, x is negative 5, y is 11. To find the slope is going to be change in y over change in x, or negative 9/12, which is negative 3/4. The tangent then, using y minus y1 equals m times x minus x1, or the point slope formula, is y minus 11 equals negative 3/4 times x plus 5, or y equals negative 3/4 x plus 29/4. Part B, find the coordinates of each point on the path where the horizontal component of the velocity is 0. The horizontal component of the velocity is 6t squared minus 6t. That would be the x component. So we set that equal to 0. Divide out of 6. We get t squared minus t equals 0. We factor and find t equals 0 and 1. So r of 0 is 0I plus 0j, or 0, 0, right at the origin. R of 1 is 2 minus 3I plus 1 minus 12j, or negative 1I minus 11j, or negative 1, negative 11.